So let's talk about exceptions. I've made this Trello board and it's got the 3 lanes that I talked about. We've got to do, in progress, and done. And over here I've made a card for each of the topics that I want to talk about in this lesson. And you'll see that some of them are red and some are orange. Those are called labels. You edit them by going in here. And I'm using them to denote the things that I'm going to try and talk about in this video are red, and then the next video is orange. Okay, so when I start working on a task, I want to grab the card and move it from to do into in progress. Syntax of try catch. Okay, so this will be probably familiar because we've done some fairly advanced projects and stuff that involves exceptions, but I'll go over it again. So I'm going to start out with a brand new fresh project this time. And the reason for that is because you guys have been cloning and importing all my code, I want to make sure that you're able to do it by yourself. Specifically, actually, because of this module stuff. Okay, so what it's asking me now is if I want this project to be a modular project. Java before 9 didn't have this feature, so if you're at 8 or below, then you won't get that option. But yeah, so it can be a little tricky. That's why I'm going to do it that way. I'm going to do it this way today. Okay, so let's start with an empty class. Okay, so it's initially giving me an error right away, and that's because if you have a modular project, you need to use a package. All your code needs to be in a package. You can see over here that I'm in default package. So I'm going to right click and make a package. I usually put my stuff in examples like that. And then I'm going to move my class in just by dragging it. And now my error's gone away. The modular stuff, it's new and it can be useful for if you're working on very large systems. For us, just having the packages themselves is a good way of organizing things, but imagine if you had a ton more code, it's another way to package stuff and make it modular. So it's important that you know about it. How do I delete that? It won't let me delete it. Okay, so I'm here to talk about try catch. Stay on point, girl. All right, so what I'm going to do is I'm going to show you the basics of try catch, and I'm going to make a URL. Okay, so the URL I'm going to put in here is this website that you should know about. Stack Overflow. This is where you go when you have errors, and you can get answers from other developers. Probably if you Google some sort of a problem, you're likely to be sent here anyway, but it is important that you know about this. And also, you can build up a reputation on Stack Overflow, and that's considered to be as good as having a good GitHub portfolio when you're doing job interviews, when you're looking for work. So if you happen to be able to answer any of the questions on here, that's impressive for employers. You've probably seen me using it here and there when I was correcting things. All right, so I'm just going to do this. So the reason that it's red now is because it wants to throw an exception, but I'm not quite there yet. I'll show you about that in a second. I just disliked my own naming while I was typing it. All right, so let's see if we can connect to this website. Open connection. Because I'm pretty sure that will give me another type of an IO exception. All right, so can you see when I'm hovering over here, it's saying unhandled exception type malformed URL exception. And then this second line is saying unhandled exception, type IO exception. All right, those are two different things that can go wrong. And that's why we have different kinds of exceptions, because it helps you pinpoint the problem. Okay, so for now, I'm just going to do this add throws declaration. No, you know what? I'm going to do the other one first. Okay, I have two options. I can add throws declaration or surround with try catch. But we're talking about try catch right now. So I've surrounded that with a try catch. This guy's hanging out on his own. So I'm going to move him up into within the try block. All right, and then this one, since it throws another exception, I'm also going to add it to my existing clause. Add exception to existing catch clause. It's not actually what I wanted. I wanted one below it because it's a bit more obvious. Yes, sorry. I wanted to add it to the existing try. So the reason I'm putting them together in one place is if this is not a well-formed URL, then I don't want to go ahead and start doing the connection with it because it's not a good URL. So the reason we have this try block is if this fails, it's not going to try and do this. So it's a way to put things together that you expect to happen together, and if they were separate, that would be not good. Okay, so the syntax of this thing is that we've got a try and then a curly brace, and then we can have, we need at least one catch clause, but we could have more than one like I have here. Okay, I think I can move this card along now. That's the basics of the syntax. Okay, now let's talk about how the most specific exception must be caught first. Okay, so I have two exceptions here. I have malformed URL exception and I have IO exception. Well, I know from the rules that the IO exception must be the more general one. And what do I mean by general? Well, by that I mean that I could actually get rid of this malformed URL exception and still my code would be fine because malformed URL exception is actually a kind of IO exception. I'm going to go into the code and have a look-see. Okay, this is the Java class for malformed URL exception, and you can see that it actually extends IO exception. That means that malformed URL exception is a more specific version of IO exception. Okay, so it wouldn't make a whole lot of sense to have these the other way around. I'm using my Alt key to move this up, so I'm going to select the block and then go Alt up. But I actually should have left that curly brace where it was, down. Alright, so now I'm getting an error, and that is unreachable catch block for malformed URL exception. It's already handled by the catch block for IO exception. Okay, so if either of these things go wrong, it's still going to get caught by IO exception. And you could even say the same for the parent of IO exception, which is exception. So if I wanted to not be specific, I could just catch the general class exception here, and that would also be okay, once I use the curly braces correctly. Okay, so that is about the ordering, and that's why the most specific exception must be caught first, if there's more than one. Okay, finally is always executed. What is finally? Okay, finally is this thing that always happens. Put all this stuff back in. These to-dos are making me a bit nuts, so you can go away. And actually this needs to go up again because I was messing around. Okay, so you have the option of putting in a finally block. And the purpose of that finally block is to tidy up resources that you may have been using up here. Alright, so just to show you that this is going to happen, okay, so when I run this, no matter what happens, and I'm pretty sure I'm going to get an exception now, Yes, I'm getting an exception. It's always going to say, do I always have to be called, whether there's an exception or not. All right, why is there an exception? I'm having a malformed URL exception. That's the first one. No protocol. So I would have to put in the protocol here, HTTP, try that. Okay, so even though I have no errors, I'm still getting what prints out of the finally block. Do I always have to be called? That's what finally blocks do. Okay, I'm going to show you a little sort of pattern, which is how you would mostly use try catches. All right, so say we have these three things. I want to open a database connection. Then I want to get stuff from the database. I don't know if you guys are familiar with those acronyms. Okay, so if I was doing this, I don't want to get the stuff from the database if the database cannot be opened. So I put a try in here, and then I would catch it. Here, underneath the second line. And then I would put my code that does those two things together. So that means that if the database connection was not able to be opened, then it's not going to try and get stuff from the database. The purpose of the finally might be close the database connection. We want to do that all the time. Okay, so that's an overview of the purpose of these things and the syntax. Did I get my task done? Finally is always executed. I think I did. Hierarchy of errors and exceptions. Actually, I want to do this one first because I made slides. She actually made slides. There must be a blue moon out. Okay, throw and throws. Okay, there are two very similar sounding words, throw and throws. You use throws in a method signature. You use throw when you're making a new exception. I'll show you. Okay, so let's get back to where we had that connection to Stack Overflow. Here. Okay, so I'm going to get rid of where I'm doing the exception handling so I can show you another way. All right, so we're back to this lovely redness. Okay, so I had two options before. One, to fix it. One was to surround with try catch. We did that. And the other is add throws declaration. Okay, so you can see it's adding it to the method signature there. And what that means is that the exception is not going to be handled here in this main method. It's going to bubble up. And it doesn't make too much sense when we're in main, but you'll see later when there's a string of calls, then you might want to pass the exception up to the calling method. Okay, I'm going to say throws there. Sometimes, if the exceptions were very different, you would get the exception and then a comma, and you could have a whole string of them. But because we saw that malformed is a child of IO exception, then this covers it. Okay, so what we're essentially doing here is not dealing with our own potential problems. You're just handing it off to whoever's using the thing next, which sometimes you want. Okay, so throws goes there. Now, on top of that, I could actually just throw my exception by myself with no code. And how you do that is you throw new. Okay, not throws, throw. Okay, it's red because I need to add my throws declaration. All right, so this is how you initialize your own exception. You might want to do that sometimes. Okay, that's about throw and throws. Now I want to show you about this special runtime exception. Okay, so runtime exceptions are things which could happen unexpectedly, but if you were dealing with them all the time, you would just have them everywhere. So runtime exceptions are special. They are what we call unchecked. All right, so I'm going to show you what happens. when I take this throws out, I've got red, but if I change this to runtime exception, now it's fine. Isn't that strange? Okay, so that's what it means for an exception to be unchecked. So you don't actually have to handle them even though they may be happening. All right, this is to give you a little perspective on how these things are connected to each other. All right, so the things that are blue, those are checked exceptions, and the things that are red, those are unchecked exceptions. Well, there's also error, which isn't technically an exception, but it's kind of like it. Here are some familiar things. IO exception we've seen before. We've seen malformed URL exception. SQL exception, that would be if there's a problem with what you're executing on the database. Very common. And here are some runtime exceptions. See, these can happen a lot. You've got a null pointer exception. If you were checking for every null pointer, you would be pretty annoyed. Class cast exception, number format exception, and index out of bounds exception. Those are just too common to want to catch them every time. So we will actually see them happening. I'm going to run this so you can see the exception coming down here in the console. They do happen, it's just that I'm not forced to deal with them. Okay. And yes, the thing about these is that exception and error, they both extend from throwable. So runtime exception, open that class. Runtime exception extends exception, and then exception extends throwable. I made this diagram, I think, a long time ago, and these, as you know from UML in the last course, those arrowheads should actually be open because that's an is-a relationship. Those are inheriting from each other. Okay, let's talk about this guy, error, for a second. Okay, so an error is a really, really bad thing. And it's a serious exception that's thrown by the JVM, by the Java Virtual Machine. When this happens, we're pretty much screwed. There's no way out of it. So that's, in a different category of things from an exception. Here's some examples. All right, Stack Overflow error. No class definition found error. Can you imagine if it can't find the class, then it can't run? That's a big fat error. Stack Overflow error. You get this sometimes if you use recursion, but you mess it up. Personally, I hate recursion, which is why Keith is going to be teaching it to you in Java 3. Keith's the best. Okay, and it's unchecked. And the reason it's unchecked is that, if you have any of these kinds of errors, not really a whole lot you can do. There's not much point in trying to recover from it. But exceptions, we can at least prepare for those. And we're going, so when you have an exception, you're figuring out if this bad thing happened, what would minimize the impact to the user? Okay, how am I about with my Trello? Did I tell you about throws and throws? Yes. Did I tell you about the hierarchy of errors and exceptions? Yes, I didn't. These were on my slides, so I did that. Difference between errors and exceptions, done. Checked versus unchecked, done. I should have labeled this one red because I actually do want to show you about stack traces. That's the other thing that I'm going to talk about in the next lecture. I'm going to show you how to make your own. All right, how to read a stack trace. Essential business. But generally these are more complicated. Here we just have one line, but usually we have a deeper call chain. And by that I mean there's a method that calls a method that calls a method. It's not just one method deep, which is the main method. So I'm going to show you how it looks in Game of Thrones. So first I'm going to run my Game of Thrones unit tests to make sure everything's cool. And now I'm going to deliberately break something. So in my file helper, I'm going to come in here and I'm going to break this path by putting some kisses on here. Run my test. And then we get all this gnarly, this is what you call a stack trace. Obviously my assertions failed and I got a red bar. Okay, so this is a nice error message. They're not always this nice, but it's telling me that there was a file not found exception and that there was no such file or directory as this. So that might be fairly easy to find because it has the string of the actual file path. But if you didn't have that, you would need to actually dig through this trace and make some sense of it. Right, so this is pretty hefty. I'm going to make, whoa. What's going on? Well, first of all, it seems like there are two identical stack traces printing. So just so that you can know that we actually only want to take a look at half of this. And what this is showing you is all of the method calls that happened when you ran that class. So this first one, remote test runner, that's something that runs your unit tests. Your unit just runs your JUnit and runs your test cases for you. And that's in its main method. And then the next thing it calls is the run method of that same class, remote test runner. And then it calls that method, and it calls that method. That's a delegated method. And then it calls this method. And then all the way up, this is all stuff that's inside of JUnit. See, I can tell because it has the package name there. And then at some point, it calls my code. All right, so knowing how to search for this is important. And you can do it this way. So I know I've got like a project name, it's lesson 9, and then I'm also seeing my package here. So that would be specific to me. So that's telling me that here's the stuff that I actually have the ability to fix. Okay, so I can click on these. The problem is happening in test source is the saddest. That's the test that's calling the method that has a problem. And then just by looking at the stack trace, I can see that it's the load metadata method inside of file helper, and it's exactly pinpointing it. So though I've changed the file path there, where it's actually causing a problem is, let me click on you again, there. Problem with the file reader, and I know that because I'm reading a little bit ahead on here. This is actual inside of Java, so you wouldn't be able to easily change this. But that's what happens if you click on stuff that's not your code, you're going to get, yeah, so it's the source code for Java. There's a lot of comments in there. Okay, so now it's printing the stack trace. I want to show you a few different ways I could have done this. So here I'm catching an IO exception. That is like if this file is not found or cannot open, then these things are going to be done together. The reason I have them in here together is so you have, I'm making a buffered reader and then I'm doing all this reading, and if I'm not able to make the buffered reader, then I don't want to start trying to read from something that doesn't exist. So that's why I've put it all in one try block. And then here I'm printing the exception. I was using that for debugging. If I comment this out and I run it, I'm not getting any stack trace. So that's where that was coming from. There's a few different ways to deal with your error message. So you can actually just print out the exception, E. There we're getting file not found. I could also do e.getMessage. That's just going to give me just the specific reason why it failed. Like that. No such file or directory. But a lot of the time you need to use this print stack trace, which is why if you automatically generate your own try catch, it usually puts in a stack trace like this. It usually does. Print stack trace. Okay, so that is how you read a stack trace. It's an extremely important skill. Oh, and what I was talking about with Stack Overflow earlier, let me see, this is kind of how you use Stack Overflow. A lot of the time you take the stack trace. So here it's like, file not found. This is not a very good example because it's very specific. So this whole string is relating to my project only. Stack Overflow, and then jam in your exception. And then you'll see people that are talking about it, and then you'll see solutions. The top solution is going to be here at the top. This shows how many votes it got. And then that's a really good way of troubleshooting your problems. Stack Overflow. Okay, how are we with the Trello? Let's see. Why did you close my Trello? Oh, here we are. Okay, I think I've talked enough about how to read a stack trace, so I'll move that into the done column. And the rest of these I'm going to talk about in the next video. So for practice, I just want you guys to do the quiz that's in there. It's a little bit tricky, but you should really just, my idea is that you'll be learning while doing the quiz also. Okay, talk to you again soon.